Well, greetings, Algebra 2ers. Today we're going to cover section 1.4, and it has to do with solving equations. Solving equations. Many types of equations. An equation must have an equal sign. Okay, it makes two things equal. If it's just an expression, it doesn't have an equal sign. So no equal sign. There are many properties of equality when you're solving equations. And most of these are pretty obvious, but we do give them names. The first one is reflexive. It's like looking in a mirror. It's just saying like A equals A. Whoops. A equals A. Or in numbers, it might be like 5 equals 5. And that seems like a very simple idea, but it does become useful later on. There's also symmetric. Symmetric, if something's symmetrical, it's like equal on both sides. So if A equals B, then B equals A. So if 1/2 equals 0.5, then 0.5 equals 1/2, forward and backwards. Then we have one called transitive, and to transverse or to go across, it translates from one to the other. So if A equals B and B equals C, then A equals C. So using this same idea here, if 2.5 equals 2.5 and 2.5 equals 5/2, then 2.5 equals 5/2. Okay, and the next one, I'm going to go to the next page. We have substitution. And that's if A equals B, then A can replace B, and vice versa. So for example, if A equals B and A plus 9 equals 15, then B plus 9 can equal 15. So you can just replace the A with a B. That's substitution. All right, keep going here. The addition rule for equality. If A equals B, then A plus C equals B plus C. So you're just adding the same thing to both sides. Subtraction rule. Okay, we still have if A equals B, then A minus C equals B minus C. Multiplication rule. If A equals B again, then A times C equals B times C. So you can multiply both sides by the same thing. And then division. A equals B, then A over C equals B over C. So you can divide both sides by C. So these are all just the names. You've used all of these in algebra. This shouldn't be too unfamiliar to you. So a very simple start. X plus 4 equals -12. I'm going to subtract 4. That would be the subtraction rule of equality, and I get x equals -16. Done. Okay, if you want to check, you put this back in right here. -16 plus 4 equals -12. It works. All right, let's try a little bit more challenging one. -27 plus 6y equals 3y minus 3. All right, first thing I'm going to do here is I'm going to distribute this. So -27 plus 6y equals 3y minus 9. So that's the distributive rule. Then I am going to do this to both sides, and that leaves me with plus 18. So I'm going to call that the addition rule for equality. Then I'm going to subtract 3y from both sides, so I get 3y equals 18. That would be subtraction. Then I get y equals 6 because of division. Okay, so I may have you write those in when you do some problems. So just be aware of the steps that you're taking. All right, next one. Let's say we have the formula 2w plus 2l equals p. That's the width and length to get the perimeter. So I have width, and length, and then perimeter would be all the way around. All right, so we're saying that x is the width and 3x is the length and 200 is the perimeter. Okay, I want to solve for x. So I'm going to plug this in where I see width. I'm going to plug this in where I see length. And then this goes in where I see perimeter. So 2x plus 2 times 3x equals 200. Okay, all we did there was substitution, because I said x was the width and w stands for width. So I'm just substituting x in for w. Then I'm going to do this. And all we did was multiply in there. We didn't multiply to both sides, so we really just simplified. Okay, we'll just call that simplifying. Putting these two together, you can either say add like terms or simplify again. And then the last step is division. And there we have it. So my width is 25 feet or whatever it is, inches, and my length is 3 times 25, so it would be 75. So then perimeter all the way around is 200. Okay, this next one is going to be a little different result. Okay, so on this one, I'm going to get my like terms together first. I have 11 and negative 7. That would be 4. And then I have 6x and a minus 3x. So that would be 3x. Okay, the next thing I'm going to do is I'm going to subtract 3x from both sides. And that actually, they disappear completely, and I end up with 4 equals 5. Now, I don't know about in your world, but in my world, that's not true. So this is never, come on, this is not, let's go again, not true. Okay, so we'd say never. And the next one, plus 5 minus 2x is 4 plus 4x minus 1. Let's simplify a little bit here. I have those two as 4x. Then I have 4x, and then these two. Actually, this should be a plus 1 here in the end, so I get a 5 plus 4x. Subtract 4x. I get 5 equals 5, and that is always true. So we can write down always true. So these two equations, or these two expressions, this is always going to be true, this is never going to be true, and the ones that come out like we had before, something like, you get x equals 4 at the end, so that equation is sometimes true. It's true when x equals 4, but it's not true other times. This one is always true. No matter what x I put in here and here, this statement's always going to come out true. No matter what x I put in up here, This is never going to be true no matter what x. And this is only sometimes because it's only when x is 4. So we have always, sometimes, and never. All right, this next one is called a literal equation. Now these show up a lot in chemistry and physics. A literal equation has 2 or more variables, usually more than 2. If you see the phrase solve for x in terms of y, what that means is they want you to get x alone, and then over here is going to have the y in it, along with some other things. So solving for x in terms of y, you get the x alone. All right, let's start with centigrade is 5/9, and then Fahrenheit minus 32. So this is converting from Fahrenheit to Celsius. Now what I want you to do is solve for F in terms of C. Now this is not in terms of C because solving for F, I need F to be alone here, and then something with C in it on this side. So I need to get this letter F alone. First thing I'm going to do is I'm going to multiply both sides to get rid of this fraction, multiply by 9/5. So I have 9/5 C. This cancels to 1. Boy. Then I have left F minus 32 over here. To get F completely alone, I'm going to add 32. Now I can't really add 32, so I just say 9/5 C plus 32 equals F. Now normally we put this by itself first, so I'm going to switch these around. F equals 9/5 C plus 32. And what we did right there is the symmetric rule. We just switched them around to make it a little more proper. Okay. Now I'm going to do one more, and I kind of already showed it here with the fraction stuff. If you have fractions in your equations, let's write one down. 1/2 x minus 2 equals 3/4 x plus 5. Most people don't like to work with fractions, so we're going to get rid of the fractions first. And the way you do that is you multiply by the common denominator, and you do every part. Multiply by that. Now our common denominator between a 4 and a 2 is a 4. So I'm going to multiply this whole thing by 4. Now if you want to think of it as 4/1, you can. So 4 times 1 and 1 times 2, and then we just leave this. And then this, multiply this by 4, I get 4 times 3/4, and then x plus 5. In fact, I'm just going to change that to 12. So now 4/2 here is really just 2. Over here, 12/4 is really just 3. Oops. And so now this becomes a very simple equation. So now I'm going to distribute 2x minus 4. Distribute here, 3x plus 15. I'm going to subtract 2x. So I get -4 equals x plus 15. Then I'm going to subtract 15. So -19 equals x. Using our symmetric rule, we can say x equals -19. Okay, so to get rid of the fractions, just multiply each part by the common denominator. Okay, all right, that's it for today. Ta-ta for now. I'll see you in class.